I'm Pat Dugas, and this screencast is about determining whether a relationship is a linear one, and if so, being able to take that relationship and convert it into a linear relation in standard form. So the first question you may have is, how do I determine if something is linear or not? So three major things we can look at to determine that. First of all, we can look at the relationship, and if all the terms that have variables in them are to the degree 1 or 0, then it is linear. But every variable term has to be a first or 0 degree term. So for example, this, and of course we know in algebra, if there is no degree represented, it's by default 1. So here y equals 2x minus 4, we know that's linear because the x and the y are both to the first power. If any of the variable terms are not first power or 0 power terms, then it is not linear. For example, y equals x squared plus 3x, it's a second degree equation, often known as a parabola. It's a quadratic equation. A second way we can determine if something is linear is looking at it. Is the graph a straight line? If the graph is straight, then we have a linear situation. If the graph is not straight, if it has some sort of curves in it, then it is not linear. Finally, we can look at the data itself. So this is analytic, graphical, and numeric methods of determining whether something is linear. We can look at the table. We can look at the data itself. If for any constant change in the input, we have the same change in output throughout, then it has a constant rate of change, it is linear. For example, in this function, in this relationship on the left, we have the inputs going 2, 4, 6. So the inputs are changing by 2. And as those change by 2, the outputs are constantly changing by 3. So the rate of change, or delta y over delta x, as you'll learn in calculus, the rate of change with the y with respect to x is 3 y's for every 2 x's, and that is constant throughout. Looking at the situation on the right, we have increases of 2 in the inputs. For every one of those 2 increases of 2, though, we have a difference in these 2 outputs of 4, but then a difference in these 2 outputs of 8. So that right there, 4 divided by 2 is 2, so the rate of change between 2 and 4 is 4 over 2, or 2. The rate of change between these two numbers is completely different. It's 8 over 2, it's 4, so not linear. So whether it's analytically, graphically, or numerically, we can determine whether a function is linear or not. Let's take a look at the standard form of a linear equation, which is quite useful in being able to graph the linear equation using intercepts. So the standard form of a linear equation is in the form ax plus by equals c. We have capital A, capital B, and capital C, which are the coefficients in constant term for the linear equation. In standard form, a, b, and c must be integers, and a must be positive or 0. For example, the equation 3x minus 6y equals 24 is a linear equation in standard form. And the a term is 3, the b term is negative 6, and the c term is 24. Those are useful in helping find the intercepts, as you'll see in just a moment. Let's cover graphing a line using the intercepts that we can find. And of course, the standard form is perfectly set up for this. So an intercept is a point where a relation or function meets the vertical or horizontal axes. These tend to be very, very important. A horizontal intercept occurs where the output is 0, and so we'll call that h. And so the point would actually be h comma 0 because the output is 0 along that horizontal axis. We're not going up or down. We're only intercepting at that point h comma 0. The vertical intercept will occur along the vertical axis where the input is equal to 0. So it's the point, let's call it 0 comma v, where v is the amount we go up or down where we hit that vertical axis. So let's look at an example. we'll take the example we had before, 3x minus 6y equals 24. So we're going to find the horizontal intercept. Because that occurs where the output is equal to 0, we're going to set y to 0, which makes this term, this b term, this by term go to 0. So if that's 0, then what I'm left with is 3x equals 24. And if I use the division property of equality, I get x equals 8. So the horizontal intercept occurs at the point 8, 0. Okay, that's because 24 divided by 3 is 8. Now, to find the vertical intercept, I do a related thing. Now, since on the vertical intercept, the input is 0, I'm going to take this 3x term and set x equal to 0, the input. And so what I'm left with is negative 6y equals 24. Okay, so if negative 6y equals 24, I'm going to use the division property of equality. To solve this, divide both sides by negative 6. And so I'm going to get y equals negative 4. So y equals negative 4 is the y coordinate of my vertical intercept. So my vertical intercept is at 0, negative 4. Well, guess what? 2 points are all we need to graph a line. So if I take the point 8, 0 and the point 0, negative 4, which occur respectively along the horizontal and vertical axes, I now have enough information to be able to graph that line. Let's do that. Let's plot the horizontal intercept along the horizontal axis at 8, 0. And let's plot the vertical intercept along the vertical axis at 0, negative 4. So we're going to go down 1, 2, 3, 4 and plot it. Now we're going to go ahead and connect the horizontal and vertical intercepts with a line, because this is a linear function. And voila, we're done. We have just plotted the linear equation 3x minus 6y equals 24 using the intercepts. In this screencast, we learned how to identify whether a function was linear, if so, to put it in standard form, what the parts of standard form of a linear equation were, and finally, how to take a linear equation and graph it using the intercepts.